In the previous examples, we have seen that we can solve a system of linear equations by converting them into a matrix equation. And we can solve a matrix equation by using Gaussian eliminations, reducing the matrix into what is called reduced row echelon form. So for the next example, I'm gonna try to use that strategy to solve this system of equations. So first thing first, let me actually convert this set of equations into a matrix equation. I'm gonna go ahead and write the augmented matrix by just pulling out the coefficients here. So I'm gonna have 1, 2, 1, 3, 1, 2, 1, 3, and the next row is going to be 3, 6, 5, 10. And then 5, 10, 7, and 17. And my right hand side is going to be just 4, 0, and 24. Now, my big goal, my final goal is that I would like my matrix to be in reduced row echelon form. And what that means is I want my row to begin with a 1. And then this bar should be shorter and shorter. It should look something like this. And then above and below my leading one should all be 0. So this is going to be the goal that I would like to try to achieve. So let's look at my matrix now. So let me actually kind of pull this up to compare with my current matrix. It seems like my first row actually already starts with a 1. So I can keep this here. But now, because above and below my leading one should be 0, so I have to try to change this 3 and 5 into a 0. This can be done by subtracting multiples of row 1 from row 2 and row 3. In particular, I can subtract 3 times row 1 from row 2. If I do that, my row 1 is going to stay the same. If I subtract 3 times row 1 from row 2, I'm gonna get, 3 minus 3 is 0, 6 minus 3 times 2 is 0, 5 minus 3 times 1 is 2, 10 minus 3 times 3 is 1, and then 0 minus 3 times 4 is negative 12. And I would like to change this 5 into a 0 as well. So let me actually subtract 5 times row 1 from row 3 at the same time here. So my row 3 minus 5 row 1 is going to be, 5 minus 5 is 0, 10 minus 5 times 2 is 0, 7 minus 5 times 1 is 2, 17 minus 5 times 3 is 2, and then 24 minus 5 times 4 is 4. So here is my matrix at the moment. So now it seems like this looks a little closer to my final product. So here I already have my first bar. This is my leading one. And below my leading one is already 0, so I'm happy here. So now I need to make another leading one. So notice how my leading one, the increment doesn't have to be one position. So my 1 doesn't have to be like 1 position away from the previous leading one. So here I need to make another leading one. Notice that I can divide this guy by 2, but that would make a fraction here. So let me actually divide the last row by 2 and then change the 2 rows here. So then if I divide the last row by 2, this is what I'm gonna get. So the other 2 rows stay the same. And then my last row become 1, 1, 2. So I just multiply a half to row 3. And now I swap row 2 and row 3. So this is what I'm gonna get. 1, 2, 1, 3, and then 4, 0, 0, 1, 1, 2, and then 0, 0, 2, 1, negative 2. So here I swap row 2 and row 3. So this looks good. It seems like this is going to be my candidate for the next leading one. But now, well, one property of the reduced row echelon form is that above and below the leading one has to be 0. But here, I have this 1 here and this 2 here. So I have to change these two things to 0. And I can achieve this by subtracting multiples of row 2 from row 1 and row 3. So let me try that here. If I want to make this guy a 0, I can simply subtract row 2 from row 1. So let me do that. So my row 1 minus row 2, I subtract row 2 from row 1. These two guys will stay the same. 1 minus 1 is 0. 3 minus 1 is 2. And then 4 minus 2. Wait a minute. I think I miswrite something. This should be, let me see. This should be negative 12, by the way. So this guy should be negative 12. And this guy should be negative 12. Okay. Alright. So now if I subtract, let me see, if I subtract row 2 from row 1, I get 3 here, and then I'm gonna get 2 here. My second row, my row 2 would just stay the same, so it's just gonna be 0, 0, 1, 1, 2. And for the last row, I like to change this to 0, so what I'm gonna do is, I'm gonna subtract 2 times row 2 from row 3. Row 3 minus 2, row 2. So that is going to be 0, 0, 0, and then 1 minus 2 times 1, that is going to be negative 1. Negative 12 minus 4, that is going to be negative 16. So here is my matrix so far. Notice how this looks a lot like the final result already. I have a leading one, so this is my first blue bar. This is my second blue bar. Here I see a leading one. And above and below the leading one are all 0, so I'm good here. Now then, it seems like I need to make this into my last blue bar, and it is already negative 1, so what I can do is I can multiply the last row by negative 1. So, if I do that, I'm gonna get, let me see, 1, 2, 0, 2, 2, and then 0, 0, 1, 1, 2, and then 0, 0, 0, 1, 16. So this is just negative 1, let me just write negative of row 3. Good. So here, it seems like everything is, almost everything is all set except that. So let me kind of redo the same thing. So here I have 3 blue bar. I have 3 leading 1. Wait a minute, this is not leading 1. I have this leading 1, leading 1, leading 1, and I have this guy 0, 0, 0, 0. So the only thing that I'm left to do is to change this 2 guy into a 0, and then I will be in, this matrix is then going to be in reduced row echelon form. So let me do that here. So now I'm going to do the same thing again. I'm going to subtract 2 times row 3 from row 1. So row 1 minus 2 times row 3 is going to be 1, 2, 0, 0. And then 2 minus 32 is going to be negative 30. The second row is going to be, so I subtract the third row from the second row, and that is going to give me 0, 0, 1, 0, and then negative 14. And the third, so this is row 2 minus row 3, by the way. And the third row just stay the same. And voila, now we are already in reduced row echelon form. And what does this mean? Well, if I write this into the equation form, what I'm looking at is my x1. So let's see, the first equations become x1 plus 2x2 equals negative 30. The second row basically said that my x3 is going to equal to negative 14, and then my x4 is going to equal to just 16. Okay, so now this matrix basically can be converted into equation form like this. So now once again, I have the value for x3 and x4 already, and my x2, this is going to be my free variable then. So my x2 can be whatever I want. So now my solution for this system of equation is that my x1, x2, x3, x4 is going to be just let me see. So my x3 I knew already is going to be negative 14, and my x4 is 16. My x2 can be anything, and then my x1 is going to be just, if I move to x2 to the other side, my x1 is going to be negative 30, and then minus 2x2. So here, this is my solution for this system of equations.